Hi, Kayla. Okay, so let's take a look at your question here. So this is all about trig ratios, and that's what that video in 4.3 was, is that the sine of theta, it's all right angle triangles, and the rule you might have heard way back in high school was SOHCAHTOA, is the sort of mnemonic for this rule. And what that means is that the sine of the angle theta is equal to the opposite side over the hypotenuse. The cosine of theta is equal to the adjacent side over the hypotenuse, and the tan of theta is equal to the opposite side over the adjacent side. So in a right angle triangle, you know, the hypotenuse is equal to the side across from the right angle. The opposite is the length of the side opposite the angle, and the adjacent is the side that is beside the angle. Okay, so in your example here, PQR, we know it's a right angle triangle because they told you that. And they said this angle here is theta. And what they told you is that the tangent of theta is equal to root 3 over 1. And according to the trigonometric rules, the tan of theta is equal to the length of the opposite side over the adjacent side. So, if that's true, where it's root 3 over 1, the length of the opposite side has to be equal to root 3, and the length of the adjacent side is going to be equal to 1. So this is the opposite side. So the length of that side, oops, here's the opposite side. So that's root 3. Here's the adjacent side. So that's 1. So now I know that the length of PQ is root 3, and the length of QR is equal to 1. So they actually gave you the ratio right there. So to find the length then of the hypotenuse, let's just do that in a different color. The hypotenuse here, which is the side that you're missing, that's just Pythagoras. A squared plus b squared is c squared. So I know that PR, which is the hypotenuse squared, is going to be equal to the length of PQ squared plus the length of QR squared. So PR squared is going to be equal to root 3 squared plus 1 squared, which is equal to 3 plus 1, which is equal to 4. And then if I find the square root of both sides, the length of side PR is 2, because the square root of 4 is 2. So that gives me, if I look, okay, there's my length of PQ, there's my length of QR, and here's my length of PR. Okay, so then the only thing you have left to do is find this missing angle. So I know theta, or the tangent of theta, is equal to root 3 over 1, which is root 3. So I need to find the opposite of tangent. So the tangent minus 1, or the antitangent, whatever, of root 3, if I do that on my calculator, is 30. So I know that angle R is 30 degrees. I know that angle Q is 90 degrees because they told me. They told me that that is a right angle. So to find the angle P is just, well, all the angles in a triangle add up to 180. So 180 minus 90 minus 30 is equal to 60 wait a minute. Sorry, I just mixed up. I got way ahead of myself here. Okay, actually the antitangent of root 3 is 60. Root 3 is 60. So if I know that angle R is 60 degrees, angle Q I know is 90 degrees because they told me it's 90 degrees. So angle P is equal to 180 minus 90 minus 60, which is 30 degrees. So angle R is 60, angle Q, because they told us, is 90, and angle P is equal to 30. So it sort of uses your Pythagorean rule where a squared plus b squared is c squared. So you have to remember a 90-degree angle is equal to 90 degrees. And you have to remember that all the angles of a triangle add up to 180. So really the hardest piece of math here was finding the opposite of the tangent of root 3, and then just remembering these rules for right angle triangles. If you have one angle and it's a right angle triangle, if you have one angle and one side, or two sides, or two angles and one side, you can find all the other angles and all the other sides.